Have you ever been puzzled by something that seems so simple, yet it just doesn't work the way you expect? If you've ever wondered why comparing nan values in Python leads to an assertion error, you're in the right place. Today, we're diving into the curious case of nan and why it behaves the way it does. I totally get it. It can be incredibly frustrating when you think you understand how something works, only to hit a wall. You're not alone in this confusion. Many developers have faced the same question. Why does asserting that nnan equals nan throw an error? Let's set the stage. One user recently asked, if asserting that 1 equals 1 works fine, then why does asserting that nan equals nan cause an assertion error? They were also puzzled by the fact that asserting nan does not equal nan seems to work just fine. Sound familiar? Let's explore this together. So what's going on here? In Python, nan stands for not a number. It's a special floating point value that represents undefined or unrepresentable values, like the result of 0 divided by 0. Because of this, nan is not considered equal to anything, not even itself. This is why asserting nan equals nnan fails. And stick around. At the end of this video, I'll share the best way to test for nan values effectively, so you can avoid this confusion in the future. To understand why asserting that nnan equals nan causes an error, we first need to clarify what nan means. Nan stands for not a number and is a special floating point value used to represent undefined or unrepresentable numerical results. In Python, when the user checks if nnan is equal to nan, it returns false. This is because nnan is not considered equal to any value, including itself. Therefore, the assertion fails. On the other hand, when the user asserts that nnan is not equal to nnan, this assertion is true. This is why that statement does not cause an error. To properly test for nan values, the user should use the numpy function np.nan. This function checks if a value is nan and returns a Boolean result. In summary, the user should remember that nan is unique in that it is not equal to itself. Using np.nan is the recommended approach for checking nnan values in Python. Fun fact, did you know that nnan is actually a part of the IEEE floating point standard? It's designed to handle errors in calculations gracefully, but it can definitely trip you up if you're not aware of its quirks. Now let's look at the answers provided by other users. This user suggests using the function np.nan to check for nan values. They explain that nan does not equal itself because it represents an undefined or unrepresentable value, which can arise from various operations. Although np.nan is not mentioned in the CPython documentation, it is available in the math module and as a universal function in numpy. Here's the best practice I promised. Always use numpy.nan to check for nan values in your code. This will save you from unexpected assertion errors and make your code more robust. And there you have it. Now you know why asserting nan equals nan causes an error and how to properly check for nan values in your code. If you found this video helpful, please hit the subscribe button for more programming tips, and don't forget to share your own experiences with nan in the comments.